Black holes. A black hole is a region of spacetime where gravity is so strong that nothing, no particles or even electromagnetic radiation such as light, can escape from it. The theory of general relativity predicts that a sufficiently compact mass can deform spacetime to form a black hole. The topic, black holes, in overview. Types of black holes. The topic, types of black holes, in overview. Schwarzschild metric describes the gravitational field outside a spherical, uncharged, non-rotating mass such as a star, planet, or black hole. Rotating black hole. Black hole that possesses spin angular momentum. Charged black hole. Black hole that possesses electric charge. Virtual black hole. Black hole that exists temporarily as a result of a quantum fluctuation of spacetime. Types of black holes, by size. The topic, types of black holes, by size, in overview. Micro black hole. Predicted as tiny black holes, also called quantum mechanical black holes, primordial black holes, or mini black holes, for which quantum mechanical effects play an important role. Stellar black hole. Black hole formed by the gravitational collapse of a massive star. They have masses ranging from about 3 to several tens of solar masses. Intermediate mass black hole. Black hole whose mass is significantly more than stellar black holes yet far less than supermassive black holes. Supermassive black hole. Largest type of black hole in a galaxy, on the order of hundreds of thousands to billions of solar masses. Extremal black hole. Black hole with the minimal possible mass that can be compatible with a given charge and angular momentum. Black hole electron. If there were a black hole with the same mass and charge as an electron, it would share many of the properties of the electron including the magnetic moment and Compton wavelength. Quasar. Very energetic and distant active galactic nucleus. The topic, quasar, in overview. Active galactic nucleus. Compact region at the center of a galaxy that has a much higher than normal luminosity over at least some portion, and possibly all, of the electromagnetic spectrum. Laser. Very compact quasar associated with a presumed supermassive black hole at the center of an active, giant elliptical galaxy. Black hole exploration. Rossi X-ray timing explorer. Satellite that observes the time structure of astronomical X-ray sources, named after Bruno Rossi. Formation of black holes. The topic, formation of black holes, in overview. Stellar evolution. Process by which a star undergoes a sequence of radical changes during its lifetime. Gravitational collapse. Inward fall of a body due to the influence of its own gravity. Neutron star. Type of stellar remnant that can result from the gravitational collapse of a massive star during a Type II, Type Ib or Type Ic supernova event. Tolman-Oppenheimer-Volkoff limit. Upper bound to the mass of stars composed of neutron degenerate matter. White dwarf. Also called a degenerate dwarf, is a small star composed mostly of electron degenerate matter. Supernova. Stellar explosion that is more energetic than a nova. Hypernova. Also known as a Type Ic supernova, refers to an immensely large star that collapses at the end of its lifespan. Gamma ray burst. Flashes of gamma rays associated with extremely energetic explosions that have been observed in distant galaxies. Compact star. White dwarfs, neutron stars, other exotic dense stars, and black holes. The topic, compact star, in overview. Quark star. Hypothetical type of exotic star composed of quark matter, or strange matter. Exotic star. Compact star composed of something other than electrons, protons, and neutrons balanced against gravitational collapse by degeneracy pressure or other quantum properties. Properties of black holes. The topic, properties of black holes, in overview. Accretion disk. Structure, often a circumstellar disk, formed by diffused material in orbital motion around a massive central body, typically a star. Accretion disks of black holes radiate in the X-ray part of the spectrum. Black hole thermodynamics. Area of study that seeks to reconcile the laws of thermodynamics with the existence of black hole event horizons. Schwarzschild radius. Distance from the center of an object such that, if all the mass of the object were compressed within that sphere, the escape speed from the surface would equal the speed of light. M-sigma relation. Empirical correlation between the stellar velocity dispersion, sigma, of a galaxy bulge and the mass m of the supermassive black hole at. Event horizon. Boundary in spacetime beyond which events cannot affect an outside observer. Quasi-periodic oscillation. Manner in which the X-ray light from an astronomical object flickers about certain frequencies. Photon sphere. Spherical region of space where gravity is strong enough that photons are forced to travel in orbits. Ergosphere. Region located outside a rotating black hole. Hawking radiation. Black body radiation that is predicted to be emitted by black holes, due to quantum effects near the event horizon. Penrose process. Process theorized by Roger Penrose wherein energy can be extracted from a rotating black hole. Bondi accretion. Spherical accretion onto an object. Spaghettification. Vertical stretching and horizontal compression of objects into long thin shapes in a very strong gravitational field, and is caused by extreme tidal forces. Gravitational lens. Distribution of matter between a distant source and an observer, that is capable of bending the light from the source, as it travels towards the observer. History of black holes. The topic, History of black holes, in overview. John Michell. Geologist who first proposed the idea, dark stars, in 1783. Timeline of black hole physics. Timeline of black hole physics. Pierre-Simon Laplace. Early mathematical theorist, 1796, of the idea of black holes. 5. Albert Einstein. In 1915, arrived at the theory of general relativity. Carl Schwarzschild. Described the gravitational field of a point mass in 1915. Subramanian Chandrasekhar. In 1931, using special relativity, postulated that a non-rotating body of electron-degenerate matter above a certain limiting mass, now called the Chandrasekhar limit at 1.4 solar masses, has no stable solutions. David Finkelstein. Identified the Schwarzschild surface as an event horizon. Roy Kerr. In 1963, found the exact solution for a rotating black hole. Models of black holes. The topic, Models of black holes, in overview. Primordial black hole. Hypothetical type of black hole that is formed not by the gravitational collapse of a large star but by the extreme density of matter present during the universe's early expansion. Gravistar. Object hypothesized in astrophysics as an alternative to the black hole theory by Pavel Mazur and Emil Motola. Dark star. Theoretical object compatible with Newtonian mechanics that, due to its large mass, has a surface escape velocity that equals or exceeds the speed of light. Dark energy star. A dark energy star is a hypothetical compact astrophysical object, which a minority of physicists think might constitute an alternative explanation for observations of astronomical black hole candidates. The concept was proposed by physicist George Chapman. Black star. Gravitational object composed of matter. Magnetospheric eternally collapsing object. Proposed alternatives to black holes advocated by Darrell Letter and Stanley Robertson. Fuzzball. Theorized by some superstring theory scientists to be the true quantum description of black holes. White hole. Hypothetical region of spacetime which cannot be entered from the outside, but from which matter and light have the ability to escape. Naked singularity. Gravitational singularity without an event horizon. Ring singularity. describes the altering gravitational singularity of a rotating black hole, or a Kerr black hole, so that the gravitational singularity becomes shaped like a ring. The Mersey parameter. Numerical coefficient appearing in loop quantum gravity, a non-perturbative theory of quantum gravity. Membrane paradigm. Useful, toy model, method or engineering approach, for visualizing and calculating the effects predicted by quantum mechanics for the exterior physics of black holes, without using quantum mechanical principles or calculations. Kugelblitz. Concentration of light so intense that it forms an event horizon and becomes self-trapped. According to general relativity, if enough radiation is aimed into a region, the concentration of energy can warp spacetime enough for the region to become a black hole. Wormhole. Hypothetical topological feature of spacetime that would be, fundamentally, a shortcut through spacetime. Quasi-star. Hypothetical type of extremely massive star that may have existed very early in the history of the universe. Black hole neural network. The following outline is provided as an overview of and topical guide to black holes. Gravitational singularity. Or spacetime singularity is a location where the quantities that are used to measure the gravitational field become infinite in a way that does not depend on the coordinate system. Penrose-Hawking singularity theorems. Set of results in general relativity which attempt to answer the question of when gravitation produces singularities. Issues pertaining to black holes. The topic, issues pertaining to black holes, in overview. No-hair theorem. Postulates that all black hole solutions of the Einstein-Maxwell equations of gravitation and electromagnetism in general relativity can be completely characterized by only three externally observable classical parameters: mass, electric charge, and angular momentum. Black hole information paradox. Results from the combination of quantum mechanics and general relativity. Cosmic censorship hypothesis. Two mathematical conjectures about the structure of singularities arising in general relativity. Non-singular black hole models. Mathematical theory of black holes that avoids certain theoretical problems with the standard black hole model, including information loss and the unobservable nature of the black hole event horizon. Holographic principle. Property of quantum gravity and string theories which states that the description of a volume of space can be thought of as encoded on a boundary to the region, preferably a light-like boundary like a gravitational horizon. 8. Black hole complementarity. Conjectured solution to the black hole information paradox, proposed by Leonard Susskind, citation needed, and Gerard T. Hooft. Black hole metrics. The topic, black hole metrics, in overview. Kerr metric. Describes the geometry of empty spacetime around an uncharged, rotating black hole, axially symmetric with an event horizon which is topologically a sphere. Reisner-Nordstrom metric. Static solution to the Einstein-Maxwell field equations, which corresponds to the gravitational field of a charged, non-rotating, spherically symmetric body of mass m. Kerr-Newman metric. Solution of the Einstein-Maxwell equations in general relativity, describing the spacetime geometry in the region surrounding a charged, rotating mass. Persons influential in black hole research. Stephen Hawking. Stephen William Hawking, the 8th of January 1942 to the 14th of March 2018, was an English theoretical physicist, cosmologist, and author who, at the time of his death, was Director of Research at the Centre for Theoretical Cosmology at the University of Cambridge.